This is M Squared with a tutorial on how to find an angle or angles that are formed by secants, tangents, and sometimes chords. You might remember these lovely little rules. It would be good to make a little chart so that you know what the formulas are. If they intersect outside the circle, we subtract the arcs and take half to find our angle. If the vertex is on the circle, then it's like an inscribed angle, so we take half of the arc to equal our angle. And if the secants or chords intersect inside the circle, we add the arcs, take half to equal our angle. So keep those formulas in mind. If you don't have them written down, pause and write those babies down. So moving on to these examples. This is a tangent and a secant. The rule says that you subtract this arc and this arc, take half of it, and that will equal our angle. So x is going to equal 1/2 times this arc, which we don't know yet, minus 62. Well, how are we going to find that arc? Well, remember that all the way around the circle is 360 degrees. So the first thing I'm going to do is add these two, 108 and 62. And when I do that, I get 170. So now I need to find out how much more to get to 360. Or I can take 360 minus 170. When I do that, I get 190. So this is 190, and now I can put that right there because that's the arc I needed. What's 190 minus 62? That is 128. So I need to take half of it to find x, and half of 128 is 64. So my angle is 64 degrees for that problem. Now this problem, you got to use a few things. Notice they're asking for angle BAC, which is an inscribed angle. An inscribed angle is equal to half of this arc, but I don't have that arc, so I need to find this arc before I can find the angle that they're asking me to find. So then I kind of ignore this for a minute and notice what else I have. I have two chords intersecting inside a circle with one of the arcs that it intercepts and that angle. So I know, let's call this x for right now. I know that 95, the angle that's formed, is going to be equal to 1/2 times the sum of the two arcs. I don't know this arc, that's what I need to find. But I know the other part, so I only have one variable, so it'll be easy enough to find it out. It's easier to get rid of the 1/2 than to distribute it, so I always like to multiply by 2 on both sides of the equation, because 2 times 1/2 is 1, and 1 times anything is itself, so we get 120 on this side. 2 times 95 is 190. If I subtract 120 from both sides, I find out that x is 70. Remember, they didn't ask for x, they asked for this angle right here. Well, an inscribed angle is equal to half of the intercepted arc, so now I just take half of 70, which is 35, and that is the angle that they're looking for. In this circle, hopefully you can see that circle, it's two tangents that are intersecting outside the circle. Well, that rule says that the angle, which is 50, is equal to 1/2 the difference of these two arcs. So I take the major arc, the 4x plus 6, and subtract the minor arc. I put parentheses there so I don't forget that I'm minusing both of those. So now I need to fix what's in parentheses. So I get 4x plus 6 minus 3x plus 38, because I'm distributing that negative. Some people like to put a little 1 there and distribute the -1. And again, all of that I have to take half of first. I'll just finish that out. Okay, now I can combine like terms. Those are like terms. So 4x minus 3x is just x. 6 plus 38 is 44. So 1/2 of x plus 44 equals 50. Again, I want to get rid of my 1/2 because it's easier than distributing it, so I multiply both sides by 2. I get 100 equals x plus 44. So how do I get x alone? I minus 44 from both sides, and I get 66. Do I get 66 or 56? Let's see, 9, so I get 56. Sorry about that. Okay, so x equals 56, and this is M Squared signing out.